Hi guys, today we'll be looking at the remainder theorem. So what is it exactly? Well, according to the remainder theorem, it states that when you have a polynomial f of x and it's being divided by x minus k, where k is a constant, then the remainder can be given by simply finding f of k. Now you can also find the remainder besides using the remainder theorem. You can also use long division. And before we get into use of the remainder theorem, I would actually like to do a question or two showing you guys how you can utilize long division to find your remainder. So let's consider a question. What if we were given a function and it's a polynomial? This is a cubic polynomial, and we can identify that because the highest power of x is 3. So what if we are given a polynomial and the question is telling us that they want to find the remainder when our function is divided by, let's just say, x plus 1. Now, we can definitely use the remainder theorem to easily calculate the remainder. And using the remainder theorem, applying our remainder theorem, I'll use RT for short, we can safely see that in our question, our constant is 1 there. However, take note that according to the remainder theorem, you must make sure that it's of the form x subtract k. So therefore, what we'll do is state that our divisor is equal to x plus 1, and we'll set that divisor equal to 0, which implies that the value we are using is actually -1. So now, to simply find our remainder, we will just need to find f of -1. Now we have our function up here. So we're just going to perform a simple substitution. So when x has a value of -1, we are going to substitute those values into our function wherever we see x. So we'll get 3 by -1 cubed, subtract 2 by -1 squared, plus 4 by -1 plus 1. Now, if you were to plug this into your calculator, I'll do it on screen. When you are cubing a negative number, it's negative. When you are squaring a negative number, it's positive. So -1 squared, that's +1. And 4 times -1 and plus 1. That gives us -3 subtract 2, that's -5, subtract 4, that's -9, plus 1, that's -8. So that's our remainder when we apply that remainder theorem. Pretty simple. I'd say the part to remember is that whatever your divisor is, remember to always change your sign. So another example, if your divisor were set to x subtract 2, then you would find f of +2. Remember that your divisor always needs to take the form of x subtract some constant. So as in our example on screen, we were given x plus a constant. So to create the same format, we simply change the sign. Now, what we want to do for this question, I would like to show you guys the second method, which I said is long division. So for this same question, we are going to perform long division, where x plus 1 is our divisor and our function is what we are dividing. So I'm going to clear my screen here and create some space. Okay, nice. And I'm going to set up my question to look as follows. So our function was 3x cubed minus 2x squared plus 4x plus 1. And our divisor was x plus 1. Now, when you're performing long division, you only need to consider that coefficient of x, or your term in x, sorry, not the coefficient. So, or rather the highest power of x, actually, that's present if you are dividing by a nonlinear term in the future. Okay, so our divisor, that highest power of x we have there is just x. So we are going to divide our 3x cubed by x. So if I were to set something to the side, we will have 3x cubed divided by x simply gives us 3x squared. So we'll write that here. Once you have gotten your first term on top, you simply want to multiply that by each of these. That will give us 3x cubed back, as well as plus 3x squared. Now you want to try your best to line up your terms under each other, because what you're going to do is, as with any long division, we are going to perform a basic subtraction. Set aside my working column here. Now, 3x cubed subtract 3x cubed gives us 0. And I'm not going to write 0 there. I'm just going to set that aside as it's understood. Now, what's up next is that we have negative 2x squared. And I'm going to write that in my working column. We have negative 2x squared. And then we are actually subtracting positive 3x squared. That gives us negative 5x squared. So negative 2x squared subtract 3x squared gives us negative 5x squared. And we will write that right under that lineup. Next step, as with any long division, you want to bring down your term. And what we are going to do now is we are still going to consider our divisor, that x outside, and now our next step would be to divide our x into our negative 5x squared. That gives us negative 5x. Then you want to perform a multiplication where you're multiplying that negative 5x by each of these terms here. So you will get negative 5x multiplied by x gives us back negative 5x squared. And then negative 5x multiplied by 1 gives us negative 5x. Now, a trick to note is that if you have divided wrong, these terms will be different. Similarly over here. So if you have successfully performed a proper division, you will always get a cancellation of your first two terms there. Okay, so now what's left is just for us to perform our basic subtraction. And of course, those first two terms will always cancel. And then we are left with 4x subtract negative 5x. It's always worth to carry it across into your working column so that you can see clearly what you are subtracting. We have 4x subtract negative 5x. That's 9x. Then you want to bring down what's left. And now we are finally going to divide our divisor, that x, into our 9x. So x into 9x gives us 9. So we will write that on top. And finally, once again, we are going to multiply this 9 by each of these values in our divisor. Multiplying is going to give us 9 times x will give us 9x, and 9 times 1 gives us positive 9. Finally, we are going to perform a subtraction where at the end, you'll see that you end up getting negative 8 as your remainder. So that's how you would use long division to divide a polynomial given a particular divisor. And I want you guys to notice that previously, if you were to click back in the video, you would have seen when we used the remainder theorem for this question, we actually got the same value of negative 8, and that's because both methods hold when you want to find the remainder. So now that you guys are exposed to two different methods, I hope that sometimes if you have frozen in exams, you may have forgotten what the remainder theorem is all about, you can always run to this long division method and it will give you the same answers. Okay guys, so let's look at another example. So we have a polynomial and it's given by 4x cubed subtract x squared plus x subtract 2. And we are going to try to divide this polynomial. So we want to find the remainder when our polynomial is divided by, let's try 2, divided by x subtract 1 as well as x plus 2. So I'm going to do both parts both ways using the remainder theorem as well as long division, just so we can compare. So I'll draw a line here, and I'm going to set up my long division over here. So we have 4x cubed minus x squared plus x subtract 2, and we are going to divide by x minus 1. Okay, so let's try this question here. I think I want to perhaps clear that up a little bit. Okay. There we go, guys. So let's attempt this question. Okay, lovely. So we have outside our divisor, that highest power in x, we have x. So we are going to divide x into 4x cubed. That will give us 4x squared. Then we are going to multiply that by each of these terms here. So you'll get 4x squared by x gives us back our 4x cubed, and also 4x squared by our negative 1 is going to give us minus 4x squared. Now we'll perform our subtraction. Of course, the first two terms will cancel. Then we have negative x subtract negative 4x squared. I will write it to the side so you can see it clearly. We have negative x squared subtract negative 4x squared. So that's negative x squared plus 4x squared. that's 3x squared. Then we will bring down our plus x. Now we are going to divide that x into our 3x squared, and that gives us plus 3x. Now we are going to multiply 3x. Now we are going to multiply 3x by x to give us back 3x squared. And then 3x multiplied by -1 gives us minus 3x. We are going to subtract again. Those first two terms will cancel. Next in line, we have x subtract -3x. That gives us 4x. Then we'll bring down our subtract 2. And we are going to divide that x into 4x this time to get positive 4 on top. And then 4 multiplied by x will give us 4x. And 4 multiplied by -1 gives us -4. Performing a subtraction there, you'll see that our remainder ends up being equal to -2 subtract -4. That's -2 plus 4. That is +2. So we have gotten a remainder of +2. Now, what if we were to try the actual remainder theorem? Let's see what will happen. So we are going to apply the remainder theorem by comparison. So applying our remainder theorem, you'll see that our divisor is given by x minus 1, which is the standard form. So we simply need to find f of 1. Substituting 1 into our polynomial, we would get 4 by 1 cubed subtract 1 squared plus 1 subtract 2. If you plug this into your calculator, you should get 4 subtract 1, that's 3, plus 1, that's 4 subtract 2. You would get 2. And you can see that your answers when you used long division or the remainder theorem are the same because both methods work. And that's our answer. Of course, most of you guys will definitely say you'd rather use the remainder theorem than performing a long division like this. But long division tends to be very helpful in other aspects of these types of questions, and you'll see that later on. All right, guys, so that's the answer for this question. And of course, there was a second part. I'll reveal the answers. The remainder for when you are dividing by x plus 2 is -40. You can try those questions out on your own. Of course, if you want to see solutions, be sure to message me and I'll be happy to do another tutorial session on this long division. It was wonderful. I actually do enjoy doing long division. It was really lovely to be able to do a video on this topic. I haven't done it in a long time and it was fun. So guys, remember, always keep practicing maths. That's the only way you're gonna get the hang of it. And remember, there's someone always online available to help you at the click of a button. Just send a comment and I'll be there. Look forward to seeing you guys next session. Take care and bye.